Programs on Solana can't sign transactions. They have no private key. So how does a program own an account? The answer is Program Derived Addresses, or PDAs. A PDA is an address that only a specific program can control. Here's how it's derived. You take one or more seeds like a string, a user's public key, or any bytes. You combine them with the program's ID. Then you hash everything with SHA-256. But there's a catch. The hash might land on the elliptic curve, which would make it a valid key pair with a private key. That's a security problem. So Solana adds a bump seed, a single byte starting at 255. If the result is on the curve, it decrements the bump and tries again, until it finds an address that is not on the curve. That guarantees no private key exists. This is why they're called derived addresses. The address is deterministic. Same seeds plus same program ID always produces the same PDA. Anyone can recompute it. No one can sign for it. Except the program itself through a mechanism called invoke signed. Here's why PDAs matter. They let programs own state. A token account's authority can be a PDA. An escrow can hold funds at a PDA. A protocol can store config in a PDA. The program controls all of it without ever needing a private key. The common pattern is simple. Derive the PDA from meaningful seeds, like the string vault plus a user's address. This creates a unique deterministic address for each user. The program finds it, the client finds it, and they always agree. Now, let's look at the TypeScript code. We import three things from Solana Kit: the address type for public keys, getAddressEncoder for converting addresses to bytes, and getProgramDerived address for the derivation itself. We define the program address as the system program. This is the program that will own the PDA. Next, the seeds. The first seed is a string, hello world. The second seed is an encoded address. We use getAddressEncoder to convert a public key into bytes. Then we combine both into a seeds array. Now the derivation. We call getProgramDerived address, passing the program address and the seeds. It returns a tuple, the PDA and the bump. The bump is the byte that was found to push the address off the curve. Finally, we log the results. The PDA is deterministic. Same seeds, same program, same address, every time. That's PDAs. Deterministic addresses, no private key, program controlled. Next, we'll see how programs call other programs with CPI.